Okay, so we are looking at applications of inequalities. So this is systems of inequalities, but it's application problems. I haven't even taught this lesson yet, but I'm going to go ahead and post this in a minute. Well, it's going to be a couple minutes. Suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour cost $1.50 per pound. Cornmeal cost $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. So we're comparing two things. We're comparing these two types of flour, and we're going to decide which one is X and which one is Y, and then we're going to mark our graph accordingly. So I'm going to put flour down here, and we're going to say corn. Oh my goodness, it's hard to write upside down like this. Okay, so corn tortillas are going here, flour tortillas here. Okay, so that determined that flour was the X and corn was the Y. Flour cost $1.50 per pound. So I'm saying $1.50 times the X, right? Per pound. That means I'm multiplying times something. So this is going to be number of pounds. In fact, we could write that over here. Number of flour, pounds of flour, I guess you would say. LBs. Probably nobody's going to know what that means. So let me start again. Pounds of flour. And then that means the Y is the number of pounds of corn, right? Cornmeal. Okay, so $1.50 per the flour, and then cornmeal costs $2.50 a pound. So plus $2.50 a pound. Why plus? Because we're adding up all the things that we're spending money on, and then we want to spend less than $25 on it. So 25 is our total. Is it okay to spend exactly $25? Sure. So we write or equal to. Otherwise, we want 25 to be a bigger number than what we owe. Okay? So that's why we want this inequality symbol to go that way. All right. Then there's something else. It's a system, right? So we've got to write two of these inequalities. You need at least 6 pounds altogether. So when I add up the number of pounds of flour and the number of pounds of cornmeal, it needs to be at least 6. Can it be exactly 6? Yes. Yes, it can. That is okay. But I want it to be greater than this thing that I'm adding together. I want it to be bigger than 6, or it could be exactly equal to. Okay, so now we have our system of inequalities. If you were solving this on Desmos alone, you would go type this into Desmos, and then you would look to see what you got, right? But here they're asking us to write it on a graph, and so what we have to do is rewrite these problems that are in standard form into point slope so that we can graph them. Okay, I'm going to do the easy one first. I'm going to go minus x, and now I have y, the symbol, minus x plus 6. And that is one of my inequalities that I'm going to graph over here. Okay, I'm going to use the y-intercept of 6, and then I'm going to move at a slope that is negative 1 over 1. All right. Okay, so that's one of my inequalities. Perhaps I should use, and should I go ahead and graph it? Well, I kind of want to find out what this equation is and what the y-intercept is before I determine what these increments should equal. Okay, so I'm going to go rewrite this. 1.50x plus 2.50 y, the symbol 25. I'm rewriting into slope-intercept form. Okay, that cancels. Now I have 2.50. Could we be leaving off the zeros? Yes, because the number would still be the same, but we're thinking about money, so I don't know, I kind of like to leave it there. Oh no, I'm getting into my graph here. Plus 25. And so I'm going to divide by 2.5 or 2.50, same thing, and divide by 2.50 and divide by 2.50. And so I know now that I have in my second, oh, I think I was going to use a different color. I think I forgot. So Y symbol, and I'm just going to grab a calculator to do that part. 1.5, it's actually negative 1.5 divided by 2.5, and that gives me 0.6, which is, let's do math frac and turn that into a fraction. Okay, 3.5, not 3.5, 3 over 5, and it's negative X. So on Desmos, if you typed this in, then there would be a little button over there and it would look like this. So you'd type this in and then you'd probably get a decimal number. You'd click this and it will give you this reduced fraction. Okay. And then 25 divided by 2.5, and that's going to give us 10. So we say plus 10. All right. Now I am going to clean up this space a little bit more so I have enough space to graph. Just wanted to make sure you saw what I did there. So you could pause it right now if you haven't copied that down, because I'm going to erase this part. Rewind if I caught you off guard and you didn't have time to get that. Okay, so now we're deciding how to make this graph. Okay, I have to get to a positive 6 y-intercept, and here I have to get to a positive 10. I think I have enough room for 10, so I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a y-intercept of 10, and then I'm going to apply this slope of down 3 over 5. 1, 2, 3, 4, 5. Applying this slope here. Down 3 over 5. 2, 3, 4, 5. Down 3 over 5. 1, 2, 3, 4, 5. Okay, that looks pretty good. It has a line under it, so I can make this a solid line. Ooh, drawing a solid line. I got it. Okay, now decide which way to shade. Well, it says y is less than. So I would be shading this direction for that line. Okay, now let me switch colors and I'll just delineate here. Just making sure that you are noticing which line is which. Now I'm going to go up to positive 6. 1, 2, 3, 4, 5, 6. I'm going to put a dot. A negative slope of 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. Okay. And now I'm going to connect those because it's or equal to, so we know it's a solid line. Okay. Now how do we shade? It says y is greater than. So I go to where the y-intercept is, and I know I'm going to shade greater than. So where my solution is any place in here. Any place that's in between the two lines, including on the line, either the pink line or the blue line, would be okay solutions. Any of this shaded, double shaded region, okay? So then when it says write 2 possible solutions, what you're doing is you're going and finding an ordered pair. So let's find any ordered pair that you want, okay? How about right there? So that's an ordered pair. And what is that ordered pair meaning? Over 1, 2, 3, 4, 5, 6, and then up 1, 2, 3. So 6, comma 3. Well, what was the X supposed to be? Let's go back up here. Number of pounds of flour. What was the Y supposed to be? Number of pounds of cornmeal. Okay, so that means one possible solution to fit this situation. You will spend less than $25 or equal to, but you will at least have 6 pounds of flour, maybe more. Then you could buy 6 pounds of flour, and I spelled that wrong, sorry. That's a U. It's also a U over here. And 3 pounds of cornmeal. Is that the only solution? Is that like the only answer? No, because that's an answer, that's an answer, that's an answer, that's an answer. That's even these answers that are like in the middle of something. So if that's 6, right? Well, in between them is 6.5, I guess, and maybe that's 6.2 and that's 6.7. And my goodness, there's just many, many, many combinations. All of these combinations would work, including right on this line, right? Including right on that. What would that mean? That would be 5. And then I think it's 6. 1, 2, 3, 4, 5, 6. Oh, it's 7. So over 5 and up 7, that would work as well. And what does it mean? What does it mean, this point? It means that you could have 5 pounds of flour and 7 pounds of cornmeal. So 5 pounds of flour, and you could have 7 pounds of cornmeal. And that would also be a solution. It would be at least 6 pounds. Look, it's more than that. If you add these two together, they're more than 6, right? But then you're still spending less than that. In fact, that it's on this line, this is a solution that you would spend exactly $25. And I know that because it's equal to. It's equal to. If you picked a dot that was on this pink line, then I know you would have exactly 6 pounds, which is okay, which is acceptable. So the solutions to this are many, many, many. I can't even list them all. It's anywhere in this double shaded region, or it's on either one of these dots because both of these are equal to. Okay, and erase and go on to the next slide. Okay, Mary knits scarves and sweaters to sell. Scarves take 2 hours to knit, so that's the rate that she can knit. And sweaters take 10 hours. Mary would like to spend no more than 40 hours a week knitting, and she would like to knit at least 5 items per week. Okay, she's got herself a little business going on here. So the two things that we're comparing are scarves and sweaters. And so that's going to be our X and that's going to be our Y. But what about scarves and sweaters? Is it the number of them? Is it how much they cost? It's the number. It's the number of scarves and the number of sweaters that can be done in this amount of time. So 2 hours to do a scarf, 2x, plus 10 hours to do a sweater. And how many hours does she want to work? 40 is okay. So we could say or equal to, but then she wants to work less. So this is her amount of hours that she's working. So we want this to be less or equal to 40. Then she wants at least 5 items. So if I total up the number of scarves and the number of sweaters, I want that to be equal to 5 at least. But it's okay if she does more than that. So it's greater than or equal to 5. And again, you can, and I'm going to just show you how to type this one into Desmos and see what it means. So we've got our answer there, and escape out. And this is the last example I'm doing. So if you don't want to see me do it on Desmos, you can peace out right now. Otherwise, let's see what our solution looks like and what we would draw from it. Come on, Desmos. Okay, so I'm typing it in just like I wrote it. 2x plus 10y. That symbol, where do I find that symbol? Ooh, it's right under my face. It's over here. You got to hit this keypad. I don't know if it's going to let me hit it. Let's get rid of my face. There we go. Show keypad. There it is. Maybe it was there before. This symbol. Okay, and then 40. And now the other one is x plus y. It's the number of things that and then we're going to make that symbol go the opposite direction. Gosh, the keypad is right under, if I click on this, I think it's going to stop. Oh, blast. How do I put it on there? I'm just going to put this symbol because it's right under the loom. Maybe I can move this. Oh, there. That worked. Sorry. Technical difficulties. Bear with. Okay, and then we're putting 5 there. Okay, so I graphed this. Now, is this the major, most important thing in the world? No, it's not. I mean, it is a solution. It's where they're crossing, and because these are both solid lines, it is a possible solution. But all the solutions are in here, so you could pick a solution that's a lot easier to talk about, like one that's at 4, 2, right? So you could talk about this as a solution. That's a point. I like to talk about the easy ones. You could talk about 6, 0. That is a possible solution. So what do I mean though? So we said 4, 2, and then I also said 6, 0. Now let's go back to the problem and see, like, what does that even mean? Okay, so we were talking about, I need to go to presentation mode. No. Scarves and sweaters. Okay, so I have these 2 possible solutions. What do they mean? Go back to what was X and what was Y. So X was the number of scarves. So you could do a combination of 4 scarves and 2 sweaters. That would mean that she would work less than 40 hours a week, but she'd still have at least 5 or more items. Yes, because she made 6 items. Or she could do 6 scarves. But if she does 6 scarves, then she can't do and no sweaters. So that would work. She would have more than 5 items, right? 5 or more, and she would work less time here. How do I know that that's actually true? Well, I could take this 6 and 0 and plug it in right there. So 2 times 6 plus 10 times 0 is supposed to be less than or equal to 40. So that's 12 plus 0. So 12 is less than or equal to 40. So that's how many hours she would work if she did 4 scarves. Wait a minute, that's not right. I just caught that myself. Okay, 22 hours. No, that is right. Oh, no. Okay, I confused you. So 6 and 0, yes, that would be correct. That's 12. She would have spent 12 hours, but she would have had the right amount of items. Because look, if we count 6 plus 0 is still 6, and that's more than 5. But let's look at this other combination, 4 and 2. Okay, what if I substitute that in? 2 times 4 plus 10 times 2. How many hours is she going to work then? That's 8 plus 20. So she's working 28 hours. That's still much less than 40. So that still works. It satisfies. So this point satisfies the equation. It's not the limit. It doesn't have to equal 40, but it could equal 40. And that's it for this.